this video is going to be looking at geometric sequences. So the past two videos had been on quadratic sequences, and we also looked at arithmetic sequences. So now we're going to get started on geometric sequences. So geometric sequences, unlike your quadratic and your arithmetic sequences, they do not have a common difference, but instead they have a common ratio. So there's a ratio between terms which are common, okay? So we define this kind of a sequence as a sequence where the ratio between consecutive terms remains constant. What we mean by this is that if you look at T2 divided by T1, you find that it is equal to T3 divided by T2, or it is equal to T4 divided by T3, okay? So if we look at a sequence, say you have 2, 4, 8, 16, and so on. If you look at T2 all over T1, you'll find that you have 4 divided by 2, which would be equal to 8 divided by 4, which would be equal to 16 divided by 8. This is actually 2. So that is what we mean by a common ratio or a constant ratio. So with a geometric sequence, this common ratio is denoted as R. So this is denoted as R. Then you also have your first term denoted as A, just like in your arithmetic sequence, okay? So we're just going to look at the general formula for a geometric sequence, and then we go and do examples. So a geometric sequence has the general formula written as follows: AR to the exponent n minus 1. So what this actually means is that you have your first term here, and then you have your constant ratio here. And then I would like to also expand this in relation to this sequence that we have here. So we will have T1 is equal to A, which is 2, okay? So this is our first term. And then we have T2 as equal to A times R, which is 2 multiplied by 2. This is 4, okay? Let's go on to the third term. We have the third term as A multiplied by R multiplied by R. Okay, this is 2, which is the first term, multiplied by the constant ratio, multiplied by the constant ratio. This gives us 8. So another way to represent this would be to say T3 is equal to A R squared, because this is R multiplied by R, okay? But what we then realize here is that if we have n as 3, n is equal to 3, when it comes this side, we have 1 less, okay? So we have a form of AR is n minus 1. So that is how this equation comes about, okay? Let us go to examples, and then we see how this equation is actually applied in solving for questions on geometric sequences. Okay, so for our first example, here's our sequence. We have 12 minus 6, then 3, and then we have negative 3 over 248. I mean 2048, yes. So the first question is to determine the general term. We know that the general term is like this: Tn is equal to AR n minus 1. Okay, what is our A? A is equal to 12. R is equal to how much? We're going to say T2 over T1, which is equal to minus 6 over 12, and this is equal to negative half. Okay, so our general term we will express as 12 times negative half to the exponent n minus 1. So this is the first question solved. Then we proceed to the second one. So the second one says calculate the value of T6. So we know that if we're looking for T6, where we have n, we'll substitute 6. So we'll have T6 is equal to 12 to the, or times negative half to the exponent 6 minus 1. And this we can find as negative 3 over 8 when we just press the calculator. Okay, so first and second question done in just less than 3 minutes. You can now proceed to the third question, which says which term in the sequence is equal to 3 over 256. So here we know that our Tn is equal to 12 times negative half to the exponent n minus 1. So but they want a term which is equal to 3 over 256. So a term that is equal to this number. Okay, so what we can then do, we can equate this and this. So we have 12 times negative half to the exponent n minus 1 is equal to 3 over 256. Okay, and then what we will do, we will multiply both sides by 1 over 12. So this is the same as dividing by 12 because the 12 is beneath. So this will cancel. Then you'll have negative 1 over 2 to the exponent n minus 1 is equal to 1 over 1024. Okay, so how we proceed from here is we're going to look for a number which has a base of 2 that equates to this. So if I can put it, I can say 2 to the exponent something is equal to 1024. Okay, so how much will that number be? You can just do trial and error. Then you'll find that 2 to the exponent 10 is equal to 1024. Okay, let me just erase. And then what we'll do is we'll say negative half to the exponent n minus 1 is equal to 1 over 2 to the exponent 10. Okay, this is the same as negative 2 to the exponent 10. Why is this the same? It's the same because we have an even number as an exponent. So whenever you have an even number, you know that the negative will be removed. For example, 2 squared is equal to 4. Negative 2 squared is also equal to 4. So we use the same reasoning here. So what we'll then have, so we'll have negative half to the exponent n minus 1 is equal to 1 over negative 2 to the exponent 10. Okay? And then what we also have, 1 is the same as 1 to the exponent 10. So we can say this is 1 to the exponent 10 all over negative 2 to the exponent 10. It's important that this math doesn't confuse you. Okay, and then when we're here, we can do this. We can say negative half to the exponent n minus 1 is equal to 1 over negative 2 to the exponent 10. So whenever you have these exponents being the same, you can actually take them out as a common exponent. Okay, so now what we have same bases. So if we have the same basis, we can simply work with the exponent. So we'll have n minus 1 is equal to 10. So this exponent is equal to this. Okay, then we say n is equal to 10 plus 1. Then n is equal to 11. So this number, 3 over 256, would be equal to term 11 in this sequence. Okay, let's go to the last one. So the last one says, how many terms are in this sequence? Let's do it. So in this one, we're going to repeat what we did on the third question. So we have our Tn as 12 negative half to the exponent n minus 1. And then we're going to equate this to how much? To this number, because this is the last value of the sequence. Okay, so we're going to say 3 over negative 3 over 2048. Okay, and then we do what we did. We're going to divide by 12. Divide by 12. Okay, so we're going to have negative half to the exponent negative n minus 1 So this value, this term gives you negative 1 all over 8,192. And again, here we're going to look for a way to represent this as 2 to the exponent something. So you're going to say 2 to the exponent whatever will give you 8,192. So you're going to try out numbers. You can start from 10, 11, 12. You then realize that 2 to the exponent 13 is equal to this. Okay. Then we can come back. We'll say negative half to the exponent n minus 1 is equal to minus 1 all over 2 to the exponent 13. Okay. So here I just want to make a disclaimer. 2 to the exponent 13 is not equal to negative 2 to the exponent 13. The reason why this is like this, it's because this number is not an even number. Okay. But we already have a negative, so we don't need to go this route. So we'll just say negative half to the exponent n minus 1 is equal to negative 1 over 13 all over 2 over 13. So this is so that we have a common exponent, and we know that this is still equal to 1. And this gives us negative 1 over 2 to the exponent 13. Okay, let me just erase a bit. So following from that, we can now leave out the bases and focus on the exponents because we have common bases. Okay, so we'll say n minus 1 is equal to 13. Then n is equal to 14. This means that there are 14 terms in this sequence. Okay, so the second question, here are our terms of the sequence. The first question is to determine the value of T6. So once again, this question is actually similar to the one we just did. To determine the value of T6, we're firstly going to get the general term. So our general formula is expressed as this for a geometric sequence as always. A is how much? It's 27 over 4. What's our R? So our R, we're going to say 9 over 4 divided by 27 over 4. Okay, and this will give us how much? It will give us 1 over 3. So we can say Tn is equal to 27 over 4 multiplied by 1 over 3 to the exponent n minus 1. So since we're looking for T6, we're just going to substitute 6 where there's n. So we'll have 27 over 4 times 1 over 3 to the exponent 6 minus 1 is 5. And then we get our solution as 1 over 36. So we just solved the first question. Now for the second question. So here we're going to say Tn, which is equal to 27 over 4 all times by n minus 1 is equal to 1 over 972. So because we want to determine n when the Tn is this. When Tn is this. Okay, so what do we do here? We're going to firstly divide by 27 over 4. Or we can rather say we're going to multiply by 4 over 27. Okay, we multiply both sides. Okay, so when we do this, this and this cancels, this and this cancels. We're left with 1 over 3 to the exponent n minus 1 is equal to 1 over 6,561. Okay, so here you can always look for a base which has 3, which is equal to 6,561. But what I'm going to do, I'm going to introduce you to logs. So what we're going to do, we're going to say log of 1 over 3 to the exponent n minus 1 is equal to log of 1 over 6,561. Okay, then when we have this will automatically drop. So we'll have n minus 1 times log of 1 over 3 is equal to log of 1 over 6,561. Okay, so what we then do, we're going to divide both sides by this log 1 over 3, log 1 over 3. Okay, so this and this will cancel, then you are left with this equal to n minus 1. So you'll punch this into your calculator. So logs, whenever there is no negative sign inside the log, you'll get a value. So what you'll get is n will be equal to 8. Then you'll say n is equal to 8 plus 1, which is equal to 9. Okay, so it means the n is 9 when Tn is 1 over 972. Let's go to the last one. Okay, so the last question, how many terms are in this sequence? We're going to repeat what we did in the previous question, but in this case we're going to use this. Okay, so we say equal to 1 over 2916. Okay, because this is our last term of the sequence. Then we divide by 27 over 4. We divide by 27 over 4. And the emphasis is on this big division sign. So we'll have 1 over 3 is equal to n minus 1 equal to, so here you'll have 1 over 19683. And this is the same as 3 to the exponent 9. Okay? So you'll have 1 over 3 to the exponent n minus 1 is equal to 1 over 3 to the exponent 9. So what we did, we said this is 1 to the exponent 9. So this is something like this. We have 1 over 3 all to the exponent 9. Okay, then n minus 1 is equal to 9. Then n is equal to 10. So this sequence has 10 terms. Let us have a look at the question whereby we have x. Okay, so this is the third question. And here are the questions for this sequence. So firstly, we need to determine the possible values of x, then write down the corresponding sequence. Okay, so what we're going to do here, we're going to use this unique fact that r is equal to t2 over t1 is equal to t3 over t2. So this is what will help us to solve for x here. And to put this in motion, we're going to say 2x minus 4 all over x minus 5 is equal to 6x all over 2x minus 4. Okay, because this is t2, this is t1, this is t3, this is t2. Okay, then what we then do here, we're going to solve for x normally. The normal way it's done. So you'll have 2x minus 4, 2x minus 4 is equal to 6x times x minus 5. So this is cross multiplication. This multiplied by this multiplied by this. So that we get rid of what's this? The fraction. So we'll end up with 4x squared minus 8x for this one, minus 8x for this one, plus 16 is equal to 6x squared minus this gives us 30x. Right. Then we can equate all this to 0. We're going to have 4x squared minus 16x plus 16 minus 6x squared plus 30x equal to 0. Okay, so I've just erased so that we have space. So here we're going to have minus 2x squared, okay, and then we have plus 14x plus 16 equal to 0. Then we'll divide by negative 2, negative 2, negative 2, negative 2. This gives us x squared minus 7x minus 8, okay, is equal to 0 because 0 divided by any number is itself. So here we can solve for this one. You can use your quadratic formula or just factor out. Okay, then you'll have x is equal to 8 or x equal to negative 1. So these are the possible values of x. This is what we're going to do in response to the second question of writing down the corresponding sequence. We are going to actually have two corresponding sequences because when we substitute this and substitute this, you're going to get different values. So let's start with this one. Okay, so when you substitute minus 1 here, we're going to get minus 6. You're going to get, this will be minus 2 minus 4, which is minus 6. This is going to be minus 6 as well. Okay, so this will be our first geometric sequence. And then using 8, so this is for x equal to -1. So using x equal to 8, we're going to have what? 8 minus 5, which is equal to 3. Here we're going to have 16 minus 4, which is equal to 12. And then we're going to have 6 times 8, which would be equal to 48. So that's our corresponding sequences, and you can actually prove or show that they are geometric by just dividing the second term by the first term. So you'll say 12 divided by 3 is equal to how much? 4. Then you go on to say 48 divided by 12, which is still equal to 4. So we have a constant ratio. We do the same here. We're going to have -6 divided by -6 equal to 1. And for this one, -6 divided by -6 equal to 1. Okay, so this is the geometric sequence solved. And that's it for geometric sequences. In the next videos, we will be starting on the concept of summation of sequences. We'll start with arithmetic series, then go to geometric series. That's it from JNB Tutorials for this video. See you in the next video.